Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. My name is Whitney Lee. I'm a senior technical advocate at Datadog, and I'm a Cloud Native ambassador, and I'm so happy to be here today. So every week we bring a new set of presenters to showcase how to work with Cloud Native technologies. We will build things, we will break things, and we will answer your questions. So this week we have Paul Ara here with us to talk about using Cilium to enforce gRPC-aware security policies. So this is an official live stream of the CNCF, and as such, it's subject to the CNCF Code of Conduct. So that basically means please be nice to each other in chats, be nice to Paul, and be nice to me too. Thank you. And those who are joining us live in chat, I would love it if you say hello. I think it is the coolest thing ever that we're part of a global community. So say hi and where you're from. I'm visiting you from Texas right now. Paul, where are you right now?
I'm in Lagos, Nigeria.
Nigeria. How cool is that? Okay, I love it. Okay, so anyway, also regarding the chats, if you have any questions, please put those in chat as they go, and we'll make this stream more conversational and answer your questions as we go. And with that, I'm going to hand it over to Paul. Paul, will you introduce yourself, please?
Sure. Hi, everyone. So my name is Paul Ara. I work at iSurveillance. I work as a community builder focused on security. So iSurveillance is the company behind the very popular open source project Cilium. And so today I'm going to be talking about Cilium. I always talk about Cilium. If anywhere you meet me, I'm probably talking about Cilium or Tetragon.
Sometimes you
So,
talk about Tetragon. Yeah, I was going to say. Not always
so,
helium.
so it's not going to be any different today. I'm going to be talking about securing your gRPC environment using Cilium.
Awesome. That's amazing. Are you ready for me to share your screen and get started?
Yeah, sure.
Cool.
Yeah. All right. Let's do this. So just to bring some background to sort of like put everyone on the same page. I know you've probably heard about Cilium, but if you haven't heard about Cilium, so Cilium is an ABPF-based networking observability and security solution for your Kubernetes clusters, right? So what Cilium does is Cilium essentially provides networking and observability and security layer for like your cloud native environment. And the unique thing about Cilium is based off ABPF, and this obviously comes with some very like immense benefit, right? So with ABPF, Cilium is able to do things differently from like how like typically like we would do things like previously. So ABPF comes with a lot of like performance benefits. We're able to like do things in the networking stack that were previously, let's say, sometimes impossible or like sort of like difficult to do, right? And
Mm-hmm.
we're able to do this with ABPF. So ABPF also powers another sister project of Cilium called Tetragon, and Tetragon is specifically focused on runtime security. So if you're curious about that, you can always just go look at the Cilium website, or also look at the Tetragon website. But today we're going to be talking about Cilium, and we're going to be talking about gRPC. So
I already have a question about Cilium. So Cilium is a CNI, right? Like a container networking interface. Is that
yeah,
correct? Okay. And does that mean you have to install or use Cilium, choose Cilium when you're building your cluster? Is it something that you can add after your cluster is already created?
yeah. So you can have Cilium. Add it to your cluster. Like you can use Cilium as the only CNI, for example, or you could merge Cilium, for example, with another CNI. So we've seen like cases
Oh.
where people, for example, if you're in an environment that already comes with like a CNI, like say like EKS or something, right?
Mhm.
You could also do that. And also another very amazing thing about Cilium is people have found a way to make Cilium work outside Kubernetes, right? So I've seen
Oh.
there's like an open source project where someone actually some people open sourced their work about making Cilium work for Nomad, and the first time I saw that, I was like absolutely blown away, right? So
That's cool.
that's kind of amazing. I think I've seen some project also like working on like the defaults, like replacing like the Docker's Docker overlay networking layer with Cilium. So it's quite interesting, and we can go all and on and all and all and all about.
I derailed. Sorry about that. Let's get back to the purpose here.
yeah, but but today we are gonna be focused on Kubernetes, Cilium in a Kubernetes environment, and specifically in the case of where you have workloads that communicate via gRPC. All right, so if you're curious about anything related to the Cilium, what Cilium can do, you can come to the Cilium website. You would see all the different use cases for like Cilium. We've got like high performance networking, layer 4, load balancing, cluster mesh, and all of that. It's a whole lot. Cilium does a lot of things and does it really well. And if we want to dive into it, I'm pretty sure like this live stream is not going to be enough for us to cover that. So today I'm going to be talking about Cilium and gRPC. So gRPC is, if you haven't, it's literally like the word gr and PC. Right, so I'm just going to zoom in a bit. So gRPC is basically an RPC framework, and I think it's currently being managed by the CNCF. So basically what gRPC is basically like a communication framework that allows like services to communicate with each other, right? So if you think,
RPC stands for remote procedure call.
yes.
Just putting it out there. Yeah.
All right.
There it
So
is. Yeah.
just to give some context, I don't know about so many people, but like I know like back in the day when I started like coding, like SOAP was a thing, and you'd write SOAP services that communicated via XML. I remember then I was a uni student, and that stuff wasn't fun to do. But like over the years, like people really got efficient with this stuff, and like invented gRPC as a very performant way for like services to like communicate with each other, right? And so the unique thing about gRPC is very, very efficient, and it does. So if you are familiar with other protocols, say like REST, for example, one of the, like I come from like a very traditional like backend background, and you would know like serializing and deserializing JSON is one of like the biggest like performance hits like your web app can take, right? So like I remember like back in the day, we'd go look for like, hey, what's the fastest library that's able to like serialize and deserialize JSON like with a better performance and maybe like the default library like a framework comes with, right? So gRPC is sort of like built around like sort of like solving this thing. So this isn't any much different from what we are used to, right? gRPC under the hood still uses HTTP2, so it's not any much different. But basically, this one of the unique things about gRPC is, so you define your basically the contract between your APIs as a proto file, and then this way like you can have like these two services talk together using like uh, uh, a format called a protocol buffers, right? And another interesting thing about protocol buffers is, so protocol, because it's an API contract, you can specify, for example, like how you want like the specific fields this input should have. Like you can have it like strongly typed and all of that, and allow like that communication to happen between these services. So one of the places you would see gRPC being used a lot for microservices, when you've got like two different microservices communicating with each other. I mean, it's rare when it's rare to see gRPC like a direct client where the client is like a front end talking to like a gRPC backend. Usually you could do that with like a proxy or stuff. But like the dominant use case for gRPC is like having like multiple like microservices or services, internal services like talking to each other, right? And because the serialization format gRPC uses actually language agnostic. So you can write your protocol files. You can have your protocol files write them and then generate like the resulting code in Go, Python, or any other language. So this way you can have a service built in Go, easily talk to another service built in Node.js easily, and And yeah, that's sort of like one of the amazing things that gRPC brings to the table. So how does Cilium come into play in a scenario like this?
Yeah.
Um, I think I stole that from you,
It's cool.
but yeah. So we're just talking about microservices right now, and Kubernetes is how like is the dominant like platform for deploying microservices right now. We have you can easily orchestrate microservices with Kubernetes, right? Kubernetes brings a lot to the table when it comes to like working with microservices and making like our lives easier, right? Pretty much almost everyone these days uses Kubernetes, right? So that's kind of like a match made in heaven, right? So you've got gRPC on this end that makes that communication easier, and then you've got like Kubernetes on this other end that makes like orchestrating like microservices easy. So all right, so today I'm going to be talking about the major thing I'm going to be talking about is how if you have a Kubernetes cluster where you have like services using gRPC and you want to be able to like enforce you want to be able to enforce gRPC aware policies, how you would do that using Cilium. So for context, Kubernetes has this thing called a network policy, and network policies are basically how you enforce like network segmentation, right? So you can say, hey, I have this group of workloads and I don't want these workloads to be able to talk to these workloads. So before Kubernetes, we will typically do this using traditional firewalls, right? So I've got this VM with the specific IP, and I this is the only VM I trust. I only want this VM with the specific IP to be able to talk to this other VM. If it's not this IP, you have a firewall rule in place that would actually block any other IP from accessing that resource or something, for example, right? But now in the case of Kubernetes, we've got pods, and pods, you're spinning up a pod quickly, you're taking down a pod quickly, the IP addresses are changing all the time, like everything is moving quickly. So in a case like that, how do you secure all of that? Because if you want to use like the traditional firewalls we're all used to, right? Suddenly you've got an IP where you say, hey, this IP, you have a firewall rule for this specific IP of the pod. And suddenly in like 20 minutes later, the pod is down and you've got a new pod with different IP, and like it doesn't work, right? So that's the thing that Cilium, that's another thing Cilium brings to the table, right? So Cilium takes away, sort of like faces away that concept of using like traditional the traditional concept of a traditional perimeter security, where we have this security that's based on like IPs, and we expect the IP address to remain like constant. But we know like in Kubernetes or cloud native environments, generally that's not the case. So Cilium brings like something whole new, so something that's really new to the table, and say, okay, we have got this workload, and we're going to assign this workload an identity, and we're going to use this identity to be able to like enforce like our security policies. So for example, you've got a workload, you've got a group of workload, you can label, like if you're familiar with Kubernetes, you can put a label and say, hey, these are my front-end workloads, and I want my front-end workloads to be able I want my back-end workloads to only accept traffic coming from my front-end workloads, because that's where I expect the traffic to come from. But if I've got like traffic from somewhere randomly from the internet coming to my backend workload, I know that's not normally right, and I would not want that to happen, right? So Cilium brings like this whole concept of, hey, you can assign workloads identity because IP address will always change, and you can use this identity to like now enforce security policies. All right, that was a lot of talking. I don't know if
It
you
was great. Yeah.
yeah.
You did a good job explaining. So, when you are assigning identity, are you doing that with Spiffy? When I say you, when Cilium is assigning identity, is that done with a technology like Spiffy? Is that done with like certs? How is that done?
Not really. So Cilium has like an entire way. I think I can pull it. Um, I can pull it somewhere from the doc. I think.
Okay. And we don't need to I don't need to derail you into a
Yeah,
specific. I was just
Yeah,
building a mental model.
yeah,
Um, so it gives each workload identity, and that identity persists after pods go down and up, or at least like that identity is associated with that label. So
yeah.
it can be cool. Um, and then when you were talking about using IP addresses as a way to figure out which VMs can talk to about which the other VMs, that painted a nice picture for me because I haven't been around much since before Kubernetes. But I did understand that IP tables were a thing. And that seems related. Are IP tables a way that Kubernetes used to keep track of which pods could talk to which other pods?
So IP tables are sort of like uh, not exactly related in this case, but that
Okay.
it's basically a way like you route like route traffic in from like external traffic to like the specific workloads. So that's where like
Okay.
long story short, but that's one of the things eBPS does. Like eBPS sort of like replaces IP tables and like in the kernel routes the traffic to like the specific workload. That's one of the things Cilium
Uh, to
is
help
really
you
good.
understand which workloads are in which
Yeah,
nodes. Oh,
yeah.
okay, got it. That's excellent. Well, thank you. So far, the chat's been pretty quiet, but hello, everyone who did say hi. I'm glad you're here. And if you have
Yep.
questions, don't be shy.
All right. So we're gonna be doing this with a very interesting demo today. And if you want to see this demo, you can go to like the Cilium repo and GitHub. Uh, so this is this repo. You go to our
I'm putting a link
examples,
in the chat right now.
and you'll see a Kubernetes gRPC. So this is the demo app that's been prepared, and this is a nice demo app that shows about like a simple gRPC. So let's just take a look at what we have inside here. So this is our protocol. This is where like we define like the contract between like the for the API, right? So we're gonna come up with a hypothetical scenario. So I don't know, Whitney, have you ever been to one of those offices where you've got like this nice screens outside a room, and the screens will
Uh,
tell you, hey, when there's someone in a room, when a room is being used or
y-
something, right?
Yep,
Those
when it's
terminals.
booked or when it's available next. Yeah.
Yeah. So I'm gonna be using like the same like sort of like analogy here in this case to like just
Okay.
walk us through. So we've got this nice office we built, and our office is called Cloud City, right? And
Okay.
the Cloud City, it's an office. There's maybe the chief executive has like some restricted areas. Obviously, that's meant for them only. They've got like some doors that every other person, some other people should be able to access. The places maybe like the intern, because it has maybe like some private documents, like our intern is not supposed to be able to access that. Or like people with just different like security clearance in the office, right?
Uh-huh.
So this is a protofile. This is a protofile, and basically what this does is this defines like the contracts. So how basically like these two services, how they talk to each other, right? So this protofile is actually language agnostic. You could write the same protofile and use it for Python, Golang, JavaScript, and all of that. But you're just gonna ignore, so just ignore the first part of this, and we could start from line 22. That's the stuff we're really concerned with. So we've got this package Cloud City. And this is, so we've got this gRPC service installed in the terminals of we've got this gRPC service in our office, and all the terminals in the rooms all talk to this gRPC office to do things. So if you want to, for example, get where, if you want to get where, if you want to get like the location of a specific door, if you want to get the status of a door is to see if it's open or if it's closed, right? If you want to, for example, something happened, you want to request maintenance for people with like higher security clearance in the office, or if you want to like set access code, will be for like, for example, people with the highest level of security clearance can set like an access code right for the door, right? So we've got this our gRPC service. So it's quite very simple. This is the contract. So in gRPC, once if you define this right, uh, you can generate like the resulting like functions in like the specific programming language, like we'll see, and then you can write your business logic like and attach. So when the client makes the call, like all gRPC just goes and calls like the business logic for this specific program. In this case, for example, get a door, get name, gRPC would go call like the framework handles everything, call like the specific function that's attached to this get name, all the specific business logic, and sends like a reply. So this is sort of like, think of this as a sort of like a schema for like our API, right? If you were maybe doing like REST, you would have to like, it's been a while, but you would have to like do like open API. You have to like write like the open API spec for that, and some people will generate like would have to like use like the open API spec to like for the schema and like do stuff with it. But yeah, all right. So we've got this. It's got like very few methods: get name, get the location, get status, request maintenance, set access code, right? So this is a message. So like for example, in let's see. So when you say get name, you say door name reply. So let's look for door name reply. It just replies like the name. This is what the, the result should look like of that specific that specific call, right? So this is also strongly typed. You see, like this way you can specify like what each type should look like. If it's a string, if it's an integer, if it's a float, if it's an array, and all of that, you can do that here. All right, so let's look at the client code. So the client code is like the code that makes like the call. So it's quite very simple. Actually, it's easier if we look at the server code first. So this is a lot of like fancy stuff. Just ignore this stuff. This is where we've got like the actual business logic in. So when you get name, we have like the business logic, what the API should reply. Get location, same thing. So it's a very simple gRPC API, and we have this being served over and port 5051. So gRPC by default, I think uses HTTP2, so you can have like and it's secure by default. So, but you can have like the option of like running it without like certificates. So, but that's all by the side. All right, so this is quite, we've got, yeah, another thing. So yeah, we've got like a Kubernetes deployment that actually deploys this simple gRPC server. So we've got this a deployment, one deployment that has this containers that actually run like that has Python. This image actually has Python in it, and then runs like the server, runs like the gRPC server. We have a service that exposes this container, and then we have a pod we would use for like making our client request. So it's that's like the stuff we need to know for now. I think there's like a Docker file that builds like all of this, but that's not really important to the context where. But if you want to follow along, you can find this on the Cilium repo and examples Kubernetes gRPC, and you can follow along. All right. So to have everything set up, just to be sure I don't play, so something doesn't go wrong, I installed a Cilium just a couple of minutes before we started the stream. I just installed Cilium and made sure like Cilium was running okay, just so because of like maybe the bandwidth, internet bandwidth or something. So this is a cluster I created using Kind. Right, Kind is one of the easiest way to like boot up like a Kubernetes cluster. This actually, I think this runs with like Docker containers underneath, right? So I have
Kind is an acronym. It stands for Kubernetes and Docker.
Okay. Yeah. So this is it. I also have Cilium installed in this Kubernetes cluster, and you can easily do this. It's pretty straightforward. You create a cluster with Kind. So this is a single node cluster. If you have the Cilium CLI installed, you can just simply install Cilium with one command. Yeah, and that gives us like the environment we can work with. All right, so um, just to be sure, so this example in the docs uses kubedns, but kind comes by default with core DNS. It's still pretty much like the same thing, but the example, if you follow the docs, it will work the same way without any problem. All right, so this is our all right. So let's just inspect our Kubernetes environment and just see what we have running. So let's see. So now we don't have anything running yet on the in the Kubernetes environment. So I'm going to deploy our demo application. I'm going to deploy our demo application to get us started. All right. This might take a minute to have the containers full and come up with the image. Yeah. All right. Um, yep. So while we wait for that to get started, uh, we could also, in the meantime, we could let's just see that this is okay. That's running. So all right. So we've got the main. This is the main application. This is the big thing. This is the server, and this is the client. Right. Just ignore the terrible naming. I could have given that like a better. I could have given that a better name. But this is the. Okay, if we get deploy. Yep. So this is our gRPC service, and then this is the client application that's running on the terminal doors, right? All right. So the first thing we wanna do so we deploy the pods. If you looked at the definition files, we had a pod, we had the deployment, but I also want to check to see if the service was properly deployed. Yeah. So we've got like the default Kubernetes service, and we've got our service that we've deployed. All right. So back to Cilium a bit. So Cilium, we've got this concept of our different of the OSI layer, right? Like the OSI layer, we've got like the layer two, we've got like the different layers. So Cilium is able to enforce security policies at different layers of the OSI model, right? So you could do that, for example, at the layer two, where you can enforce like at the layer two. You can also do that also at the layer seven, so at the protocol level. So we're talking like HTTP, another higher level protocol like Kafka, and all of that, right? So this gRPC is a layer seven protocol, right? So it's based off of HTTP two, and it has like it's still very pretty much so the same concept about like Cilium layer 7 policies applies to gRPC, right? So if we actually understand like what happens like when gRPC, we will be able to like apply like the same concept to gRPC to gRPC. So if you get lost, you draw my attention back.
Is is layer 2 like Ethernet? What's layer 2?
So we've got this thing called like the OSI model,
Yeah, I
right?
hear
So we've
layer
got like
4
a
and layer 7 all the time related to Kubernetes, but I haven't heard 2.
yeah. So we've got like the
Ah,
physical layer where like I believe this is at the device level at the
uh-huh.
very yeah. So we've got like the
With
data
like,
link
yeah,
layer,
wires. Mhm.
we've got the network layer, and we've got the transport layer, whatever. But I think if I'm not correct, it's, again, I might be mixing this up, but I remember there are two ways, there are two models for like classifying network. It's been a while since I left college, but I remember like there's the OSI model and there's another one. But like with these days, there's also like there's been like some sort of like it's been hard to like for some of the layers things to really get mixed up, and it's very hard to
Uh-huh.
like say, hey, this
This
specifically
is true.
belongs to this layer. But as it
Uh-huh.
gets higher up, then things like become like more like clear.
Yeah, that makes sense to me.
Yeah. All right. So yeah. So if you want to see what if you've not seen what a Cilium network policy looks like, I could also show you something called an editor that network policy edit the Cilium network policy editor. It basically you can create and edit network policies with this. But
Will
basically a
you
Cilium,
zoom in on that a bit?
yep,
Thank you.
Cilium network policy is basically like this is basically like every other Kubernetes custom resource definition. The same thing, define the same way using YAML, right? And basically you can write like rules. You write like your network segmentation rules in here, and Cilium does like the job for you. So this is the same way we are going to be writing like our network policy today.
So
All
that's
right.
a
So,
different object altogether that's meant to replace the Kubernetes network policy object.
yep.
Cool.
So so Kubernetes network policies. So network policies are basically like the CNI is responsible for handling everything related to network policies. So for example, if you have a cluster and you're using like a CNI that doesn't I can't remember this I can't remember this. There's the first I remember there was a time I used to work with a cluster that was using Flannel, and
Uh-huh.
you would just apply network policies and like they won't work because like Flannel as a
That,
CNI doesn't support like network policies. So for your network policies to work, you actually have to use like a CNI that supports like network policies, right? So it's yeah, that's basically what Cilium does, and Cilium basically extends like the Kubernetes network policy. So if you use like the regular Kubernetes network policies, it will work with Cilium, right? But Cilium takes it a step further and sort of like extends this and adds like some extra features, adds some extra capabilities some extra things that are not defined in the Kubernetes network policy spec. So I think well, the doc says like the goal is to be able to take these features and merge them back into Kubernetes network policy. But
uh-huh.
I can't say much for that.
What's
uh,
what's an example of something that exists in a Cilium network policy that does not exist in a Kubernetes network policy?
so an example is basically like what we're talking about today, right?
Okay.
Right,
gRPC uh,
layer
policy.
7 network policies. Yeah, there's so many some of the very base features obviously. So like this, we've got this tool here, and you can translate between Kubernetes and Cilium network policies interchangeably for like all the things that are supported that are compatible between the two. But there are some other things that are not compatible with the two, so you can't do that with this tool. All right,
So
but yeah.
before Cilium, you would take care of level 4 by having a Kubernetes network policy and level 7 by using service mesh, like a sidecar model service mesh. But now with Cilium, you're able to do both. Is that what I'm hearing with the CNI level?
So Kubernetes, if I am not mistaken, I just have to just so I be correct. But I think I'm just going to look at the network policy spec for a minute. Yeah. So you would do this for the 3 and 4. So like
Uh-huh.
here, if you look at this network policy right here,
We
you could
zoom in a
have
bit.
like,
Thank you.
so this is a typical network policy resource. So we could have like, we could do it like, we could write these rules based on like IP address and IP address blocks, for example.
Mm-hmm.
At the protocol level. So if it's TCP, if it's UDP, so this is like layer 3 and 4. We can also like block, like for example, right, say like a specific port, we only want like We want to enforce policies like for say allow like for a specific port, or I think something in the, if I'm not mistaken, I don't know if that proposal went through, but you could also do like a range of ports. But yeah, so I
And
think
then,
this is, if I'm correct, I believe, yeah, this is 3 and 4 of the OSI layer.
uh-huh,
Yeah, so this is 3 and 4 of the OSI layer. And then Cilium takes it like, Cilium takes it like a notch up. So if I actually go back to the Cilium doc, I could show you an example of where you could write, for example, like a path, an HTTP path, and be like, hey, I want your local traffic coming from like docs.cilium.com, right? Right.
mhm,
So that's like at the layer 7, we're now dealing with, when we get our, when we're doing like specific HTTP verbs, URLs. Now you're dealing at the protocol level, like HTTP.
gRPC, yeah,
Yep. All right.
cool.
Okay. Yeah. All right. So back to where we're talking about gRPC. So now we've got the service, right? So let's just play around with the service and see the things we can do. We can do with the service, right? So this is our this is our client. This is our client. So we've got this just so in case you were not following, we've got this pod here, and we basically like shell into this pod and like start up like the client file, and then our client talks to like the server and gets like a response, right? So this is a kind of, this is like a well, it's called like a, I think, if I'm not mistaken, it's called a unary type of service where it's like a request response cycle, just like a client sends a response, a request to the server responds with something, right? So this is our, what are the things we can, let's just look at our contract or our protocol file, the things we can do. It would give us like some context. So we can get the name of a specific door. We can get the location of where a door is in an office. We can get the status of a door to see if a door is open or if a door is closed. We can request a maintenance to the door, and we can set access code for the door. But in a case like this, um, we believe like say something like set access code as an, let's say I'm an intern, right? I shouldn't be able to set an access code for the door, right? I probably should leave this with someone in the organization with higher privileges, right? So that's the demo we're going to try do today. We're going to, out of these methods now, we're going to say, hey, because it's me, I shouldn't be able to do like certain things. So I shouldn't be able to like talk to certain methods. And my actions should be restricted. Sure, I want to be able to get the name of the door. I want to be able to know where a door is, but I probably do not want to be able to set the access code for a door, right? So um, right now, from an example, we could get the name of a door like easily. So if you see this, just clear this so it's a bit clear for us to see. Yeah. So here we get name, and our gRPC service responds with like the name of the door name is spaceport door one, right? Let's try another service here. We try set access code for the door, right? We can set our access code to 999, right? That's that's one thing we can do. All right, but now this is where Cilium comes into place, right? We want to say that, hey, as an intern, the only things we should be able to do is get the name of a door, maybe get the location of a door, and maybe request maintenance. We don't want you to be able to do like certain things, and we want to be able to use Cilium to enforce like the security policies and say, hey, you shouldn't be able to do this. All right. So now let's look at our Cilium network policy. So this is okay, that's the app. This is a Cilium network policy. So this is it's a Kubernetes. This pretty much looks like the regular network policies. Like the spec is slightly different. It's different, but like by just looking at it, you can pretty much like infer what it does, right? So the kind is Cilium network policy. You have the standard stuff you will have in every Kubernetes resource, right? We have a description. Then we have a endpoint selector where we match labels. We're saying, hey, um, hey, we want to apply this policy to any workload that has this label app equals to CC door manager, right? So now let's get to like the rules, right? So you could specify ingress traffic refers to like traffic. The easiest way to explain this is ingress traffic refers to traffic coming in, right? And egress traffic refers to traffic leaving. But this might differ depending on whose person's point of view you're looking at this. You're looking at this from, right?
Nothing's easy, right?
Right? Because if let's say we have a client and server, right? So from the server's part, something is coming in, so that's ingress traffic. But from the client's side, they're sending something out, that's egress traffic, right? So, but but in our case, we're thinking about this from the from the perspective of the server, right? Because we're applying this policy to the server. All right. So from the server's point of view, we want to say ingress traffic. We want to accept ingress traffic from this labels public terminal, right? And we want to say for this port, if you remember, our gRPC server was running on port 5051, right? And like the protocol is TCP, right? And now this is where the whole layer 7 stuff comes in, right? We can specify all these layer 7 rules down to like the specific HTTP method, right? And so what does this tell us? This tells us something like very interesting, that gRPC underneath is just HTTP, right? We didn't see anything like any specific any gRPC specific verb here. We're just seeing like the regular HTTP verbs we're used to: post, get, and all of that, right? So underneath, gRPC still uses HTTP to there's everything fancy, like it uses the data is sent over a protocol and then is deserialized and all of that, but underneath it's still HTTP. And so the way we arrived at this path, you would curious to say, hey, how did we get this specific path name? Well, if you look at our protobuf, I'm just going to open this in another tab so it's easy to come back to. If you look at our proto file, right, we've got the package as Cloud City, right? We've got the service name as door manager, and then we've got the specific method as a name here. So that's how we actually derive like these names. So we've got the package, the service name, and the method. This is how it corresponds to like the specific HTTP like path, right? So, and the method is post. So now I'm gonna take this policy and apply this policy, right? So I'm just gonna copy this and let's call this policy my secure with YAML. All right, so I'm just gonna apply this to a cluster. So if you actually Cilium get a Cilium network policy, we have this policy called rule 1 in place now. So CNP is a short form for like Cilium network policy. So if you don't want to type out like the full thing, like I usually just have like aliases for everything. So you could just do kubectl get cnp, and you'll get like the network policy. All right, now let's see our network policy in action. Right. Let's try some of the methods we did previously try. So let's try our get name. Our get name method work because we want the intent to be able to get the name of the door, right? Let's pick up just because I don't want to type. I'm just gonna pull this on the dock. Let's see. Now let's see. We don't want our intent to be able to set an access code for the door because we believe that this is something someone with higher privileges should do. So let's try this, and then we see like our network
Ah,
policy actually prevents this from happening. And if you look at something that's quite interesting, is if you actually just gonna see if I can expand this. Okay. Yeah, but we pretty much have like when we try to access like the specific route, we see like the network policy in place actually prevents us. I'm actually trying to see if I can see like the status code for this. All right.
gRPC status? Yeah.
Yeah. Just gonna see. Let's do this. Yeah. So
Permission denied.
this is permission denied. So just to feel some slight differences, I think something about the spec must have changed since when like the doc was last written. But yeah, you can see like this status code corresponds to like permission denied. So if this was REST, you would probably have like a three, you have a 403, right? So that's the equivalent of this in like in gRPC. But yeah, I hope this is just an example. This is just a very basic example, and you can do far much more than this. Uh, so I hope everyone like found this interesting. I certainly did find it interesting that you can actually take like a gRPC sounds like very this complicated convoluted thing, and you can actually break this down like to the underlying protocol and write very basic network policies to be able to like segment your network. So I actually found this interesting. And yeah, if you've got any questions, you've got anything you want to say, you want to drop something in the chat, you can. I'm all ears.
This has been really cool, and I really enjoyed seeing the contrast between a Kubernetes network policy object where you can write policy for IP and for TCP, UDP, and then the Cilium network policy, which presumably you still can write policy for levels 3 and 4, but then also being able to write policy at level 7 within
Yeah,
a network policy
yeah,
object in Kubernetes. That's pretty cool.
yeah. And I believe this applies to pretty much any higher level protocol that's based off. So if you look at the docs, you would see like there's one for Kafka, there's one for like Elasticsearch, but like all of this, if this protocol is all underlying the underlying protocol, maybe if it uses HTTP underneath, then it's pretty much like easy to like uh, to work with. So yeah, and like the other things beyond like the scope of this that you can do, for example, things like host firewall, where you can have like a policy. Maybe this could be another entirely different, another different cloud native life. But yeah, where you could take the same network policy and apply it to the host, and you have like that same network policy preventing like controlling like traffic to like the host itself. Now outside like the boundaries of the container to the actual host. So
Oh,
yeah,
so yeah,
if you're
interesting,
curious about
cool.
that, you can
Yeah.
just check out the Cilium host firewall.
So generally, if you weren't using Cilium's network policy and you wanted to make policy for gRPC, how's that been done in the past?
I can't speak much to that because I believe like our gRPC is pretty much like a high level protocol. So you will want to use anything that can help you like secure like things at the layer 7. So I
Uh-huh.
imagine maybe probably like something like a service mesh. But
Yes.
sneak peek to Cilium has a service mesh functionality.
Ah.
You get everything in Cilium. There's the service mesh. So if you're curious about that too. Um, there's a section in the Cilium website that talks about like the Cilium service mesh. But yeah, pretty much Cilium is sort of like designed to like just make sort of like the sentence a lot people use a lot is reducing tool sprawl. So typically you have like maybe like you have to maintain like maybe 5 different tooling inside your Kubernetes cluster. Maybe you've got like a service mesh, you've got like a gateway, you've got this, but it's just easy to like consolidate that into one tool with a very similar like language, and it's like easy to work with. So yeah, and some
As
of these
how
functionalities, sorry.
I was going to ask, how does Cilium Service Mesh run?
Yeah, I have actually haven't played around with
Okay.
this.
That's
I
okay. It's
know
okay
ex-
to say I don't know.
yeah, I know it exists. I actually haven't actually tried using it, but I'm pretty sure like the docs has like pretty much what you're what you need. But kind of the thing I kind of personally I find interesting about this is typically, previously, you would, if you weren't using Cilium, you would have to like consolidate like different tools. So, for example, some things actually do multiple things together. So, for example, your service mesh is doing like encryption, right? It's probably you're probably also using it for like maybe like enforcing like some security policies, but like you could pretty much do that with one single tool like Cilium, or you've got like typically this ingress, this gateway API, and all of that stuff. But then you
Uh-huh.
have all of this inside one consistent tool, and you can easily work with that. And I'm sure like some of these features you can also disable them. Like you have the option to like disable some of the features you're not using. So if you have a simple cluster where you say, hey, I just need network policies, and like the rest of the stuff isn't really my business, you could
Uh-huh.
also do that.
That's awesome. Well, thank you so much for your time and your expertise today. There's some thank yous coming from chat. Someone in particular, like the editor that you showed as part of it.
Oh, oh yeah,
Yeah.
this
Oh, do you
is
want to show more? Okay. Let me get it back on the screen. There we go.
I I absolutely love this. So basically, this allows you actually visualize your network policy. So for
Mhm.
example, we could take the network. This actually we could take the network policy we're currently working with, the one from this,
Mhm.
and we can actually just upload it to. We can actually upload this policy. Let's
Oh,
see.
you have Kubernetes selected instead of Cilium network policy selected. There you go.
Oh yeah, I figured out why this one. The reason this would not work is so this tool is currently limited to like the features that work for both Kubernetes and Cilium network policy, and we have layer 7 policies in that, so that would not work. But
Okay.
yeah, basically it's a tool that helps you write like Kubernetes network policies. For example, if you're migrating from Kubernetes network policy to Cilium network policies, you could put in your Kubernetes network policies here and have like this translate them to like Cilium network policies for you. But also it helps like visualizing network policies. So you can actually you can see like there's a visual representation of like the communication on your cluster here. So you've got like all the different workloads and all of that, like how they relate to each other, what's talking to what can talk to what, like you have all of that here. And we also got like nice tutorials here and some parts of the editor where if you, and also sometimes, it's YAML, one mistake and you have like everything all like crumpled up, right?
One extra
So
space somewhere. Yeah.
exactly. So, but with this, you can easily like just filling like the values you need to fill, like you actually fill them in here, or you don't have to deal with the YAML. You just have to like fill in like the values, the namespace, the policy name, the endpoint, and you actually on this side you have like the corresponding network policies generated for you, and you can just simply like just download them locally and then apply them to your cluster. Yeah, you can also share, I believe, as a GitHub gist. And
Oh, nice.
yeah, it's quite an interesting tool. So if you're curious more about it, just go to our detailed at networkpolicy.io.
That's awesome. Thank you. Super cool. And then we also just have like a general, I really like Cilium Lab. So give Vinny some props for that. Yeah.
Thumbs up.
Cool. Well, thank you so much for sharing your time and expertise. And thanks everyone for joining today's episode of Cloud Native Live. It was great to have you, Paul Ara, here teaching us about how to use Cilium to enforce gRPC-aware network policies. I also love the interaction and the questions from the chat. As always, y'all are the best. And here at Cloud Native Live, we bring you the latest Cloud Native code on Tuesdays, Wednesdays, and sometimes Thursdays. We're around a lot. So when you have time in the afternoon, eat lunch with us. It's fun. Thanks to us for everyone who was here live today. And thanks to everyone who watches the recording. And thanks one more time to Paul. I appreciate it.